Hello everyone, welcome to another edition of Chemistry Focus. In today's class, I will explain some other atomic properties in the periodic table. You will remember that in the previous video, I have explained the atomic size and the ionic size of elements in the periodic table. But today we shall look at electronegativity, the electropositivity, and their trends in the periodic table. Don't forget that metals are electropositive in nature, whereas the non-metals are electronegative in nature. However, without much ado, let's get started. What is electronegativity? It is the ability of an atom in a chemical bond, that is, in a chemical union, to attract shared electrons to itself. And why did I say chemical bond or chemical union? I mean the shared electron. The shared electron making the bond between the two elements. Take for instance, in the hydrogen chloride molecule, the chlorine atom is an electronegative element and it pulls electron to itself, leaving the hydrogen atom to be partially positive. This situation constitutes what we know as polarity. That is the partial positive and the partial negative poles possessed by each element in this chemical union. Another example is the lithium atom and the sodium atom, which are members of the same group. Lithium atom has only two shells. The sodium atom has three shells. Don't forget that the nucleus of an atom is loaded with protons which are positively charged. The electrons revolved round the nucleus. The electrons are negatively charged. As you know that unlike charges attract, the positive charge and the negative charge attract each other, constituting an electrostatic force of attraction between the two charges. But the effect of the positive charge on the outer electron is much in the lithium atom than in the sodium atom, simply because down the group, addition of shells shear away the attractive force of the nucleus on the outer electron. However, lithium atom is more electronegative than the sodium atom. That is, the pull of electron to the nucleus is much in lithium than in sodium. Let's look at elements in group 7, strictly the nonmetals, ranging from fluorine to astatine. The most electronegative among them is fluorine, and the least electronegative occurring halogen is the astatine. In other words, electronegativity decreases than the group as it was in the metals. Now, what is electropositivity? The term electropositivity is essentially the opposite of electronegativity. It refers to the ability of an atom to donate electrons and form positive ions, that is, the cations. The electropositive elements are readily available to lose electron, to donate electron, for a chemical bond to be formed. Don't forget that this is exactly the opposite of what the electronegative element does. The electronegative element absorb, attract electron. In the group 1, the elements are all metals, ranging from lithium to francium. The highest electronegative element is lithium, whereas francium is the lowest electronegative element. However, francium is the highest electropositive element, while lithium is the lowest electropositive element. This is an opposite trend in the same group. In this diagram, as you can see, lithium is the least electropositive, while the most electropositive is francium. Take a look at the trend in the periodic table. The electropositivity of elements decreases from left to right across the period, while the electronegativity of elements increases across the period. And let's quickly consider the group. Electronegativity decreases down the group, and electropositivity increases down the group. Okay? In case you are asking, what happens when two atoms of equal electronegativity bond together? This is a very good question. In fact, same tendency to attract the bonding pair of electrons can be explained using chlorine atom and another chlorine atom. Both are bonded together, having the same amount of power to attract electrons. This is a 50-50 scenario whereby a non-polar bond is formed. Unlike what I described in the hydrogen chloride molecule, whereby a polar bond is formed between hydrogen and chlorine atom. This diagram has shown exactly what ionic bond and unequal sharing of electron looks like compared to the non-covalent bond as a result of equal sharing of electron, the 50-50. Unequal sharing is described in polar compounds, whereas equal sharing is described in the non-polar compounds. For the sodium ion and the chloride ion, this is a very good example of polar substance, which this diagram describes the electronegativity of chloride ion and the electropositivity of sodium ion. The partial positive charge and the partial negative charge constitute polarity. A quick recap of today's video. Electronegativity increases across the period from left to right, while it decreases down the group from top to bottom. Equally, electropositivity decreases across the period, while it increases down the group from top to bottom. For more educational content, kindly like and subscribe. And don't forget to share this video. Join me in the next edition, and I will be glad you did. Thank you and bye for now.